going to look at forming conclusions. So how scientists use their information and the data that they gain from experiments to form a conclusion and then communicate their results. So just like the last video, some of the notes I'll type out over here on the side, and then some of them you'll have to come up. So first off, what is a conclusion? So a conclusion is something based on your data and observations from the experiment. All right, so it's a final idea, all right, or you could say a final inference based on observations and data from the experiment. And that's the key. If you don't have observations and data from an experiment, you can't make a conclusion. So you have to look at your data and then make an inference to reach a conclusion. And there are a couple different things that a conclusion should have to have. All right? So the big things are we need to accept or reject your hypothesis and explain why. Right? We have to use the data to explain why you accept or reject your hypothesis. So you might say, I accept my hypothesis because puppies grew bigger when fed Purina dog food. You can't just say, I accept my hypothesis, period, end of sentence. There needs to be a because, and you need to talk about the data that you found. All right. The other thing is you should identify your variables. All right. Our independent variable was this, the dependent variable was this, the control was this, or we didn't have a control in this experiment. And then the last thing you need to do is consider any errors and think about, could you improve your lab? All right. So, did anything go wrong? Did you forget to feed the dogs one day? Did that affect your results? Maybe the error you made wasn't a big deal, right? Maybe your experiment went for 3 months. You forgot to feed the dogs one day out of those 3 months. Probably didn't affect your results. The dogs were probably unhappy. But scientifically, your results would be fine there. Now, if you forgot to feed them for, a month, there's going to be other problems. But anyway, you get the idea. All right, the next thing we want to do, right, so we've got our conclusion. We want to repeat our results, or repeat our work, rather. Now, sometimes we can do this in the original experiment itself. And if we have reproducible results, right, that means we should get the same results every time. Right, to reproduce means to make again. So reproducible results means that you get the same results every time you run an experiment. And we mean mostly the same, right? If you first time around got 60% of the plants grew faster with this new fertilizer, and the next time only 58% did, scientifically we would probably consider that close enough, right? If 30% did the second time, that's a big difference. So you've got to use your judgment a little bit to see, are these pretty close to each other, right? And the key is that we want to use a large sample there we go, size, which reduces error. There we go. So a large sample size is going to reduce our error. We're going to have more different tests to look at. We can average those together. So while you're doing your experiments this weekend, your at-home experiments, this is definitely something to consider. You want a large sample size. Right now, you're not going to have 15 samples. Maybe for your one at home, you might have 3. So generally, if you can have like 3 trials of each thing, that will give you a better idea of if your results are valid. So one thing that we can form after we repeat our work many times is something called a scientific theory. All right, so this isn't a step in the scientific method, but we're just going to kind of jump in with this. And a theory is a word that has a special meaning in science, right? It's not just a guess or an idea. A theory is an explanation of how something works in nature, right? And the key is that a theory has been tested many times and never been found wrong. Right? So in science, we can't necessarily absolutely prove something right? It's almost impossible to prove every possible thing that could happen. But a theory, something like the theory of gravity or the theory of evolution, These are things that have been tested many, many thousands to tens of thousands of times and have never been found wrong. So in science, when we talk about a scientific theory, we're talking about a fact, something that we know for sure. Theories can be changed if we get new information, but until we do, we work under the assumption that the theory is correct, right? It's been tested hundreds and hundreds of times based on evidence and based on experiments, so these aren't guesses. We have lots of information, but they've never been found wrong. All right, last one. All right, we've got to publish our results. All right, and you're going to come up with your own notes for this side, but I'm going to work through explaining it. So come up with your own notes. Yay. All right, so when we publish our results, we always write up our results in a formal lab report. All right, and the reason we do this is to explain our results to other scientists. We want to share our results with the world so that other people can use it. That may seem a little silly if you're testing how fast Alka-Seltzer dissolves, but the principle is the same. When professional scientists share their results, they let other people hear what they have learned. So all of your write-ups include the following things, right? So in your notes, you might not want to write every single thing on here, right? But maybe just a list of the important parts that need to be in the write-up. So rather than like the specific little details, you might want to say all write-ups include problem, hypothesis, materials, and procedure, observations and data, and the conclusion. And if you notice, this is what we did in our lab reports when we wrote them in class the other day. And this is what you'll do to finish up your scientific method project at home. So we publish our results to share our results with the world. All right. That is all. These are our last notes for our scientific method unit. All right, this should be page 11 in your table of contents. All right, make sure you write a summary at the bottom so that you get full credit for your notes. And I will see you in class tomorrow.